we talked about atomic mass, the mass of an atom, and molar mass, the mass of a mole of an atom, of atoms. Here we're going to talk about a formula mass. So this is the average mass of an individual molecule or an individual formula unit. Ionic compounds do not have molecules. So we refer to their smallest unit as a formula unit. These are sometimes called molecular masses or molecular weights because the weight of the molecule would be the same number in atomic mass units. So here we're looking at the sum of the masses of the atom in a single molecule or a single formula unit. So we're just going to add the masses of all the pieces, and there we have it. So the formula mass, look at how many of the first kind of element are there times the mass of that one. And then the number of the second element times its mass. So we're literally just adding up the masses of all the atoms in the molecule or formula unit. Calculate the formula mass of calcium nitrate. We have to have the formula. So we're going to get some practice. Okay? Calcium nitrate, is that ionic, molecular, or an acid? It's obviously not an acid, right? Calcium, metal? Calcium's a metal. So this is ionic. So then to write the formula, I'm trying to be positive here. That you two people can't hear what you said, so they're going to think you were right. Yeah. Because I say stuff that's wrong all the time, don't I? And I supposedly know what I'm doing. What's the charge on a calcium ion?
+2.
+2 because it's in group 2. Okay, so that's the calcium. And then nitrate. This isn't nitride, which would be N3 minus. It's N oxygens, right? And so we could guess NO2, but it's actually NO3 with a -1 charge.
Oh, the NO2 would be ice?
Mm-hmm. Yeah. And, those names and the numbers, they're really kind of picky. You really need to make some flashcards. Just have some flashcards. So I have to calculate the formula mass, but I'm not ready with the formula yet. How many of the calcium ions do I need in the formula? And how many nitrate ions?
You need 2 nitrate ions?
I need 2 nitrate ions. If I have 2 of these guys, I have a total of -2 charge here and +2 charge there. And when I lump them all together, it's going to be 0. And that's what we're looking for. Okay, so this would not be a good exam question because it's like putting multiple things together. So the exam question would be, calculate the formula mass of CaNO3 And, reading this out, CaNO3 because if it was O32, we'd say 32. So what we need is we need to know how many calcium atoms are in that formula. There's 1, right? So I have 1 calcium, and how much does 1 calcium atom weigh? That says 40.078. That would be atomic mass units, 1 atom. How many nitrogen atoms are in the formula? 2. Because I have this bundle pack here. I have 2 of them. Each of these packages has 1 nitrogen, so there's 2 nitrogens. And then I need the mass of nitrogen, which is 14. I'm just going to say 14.01. Oops. Atomic mass units. How many oxygens? 6. 6. And with 4 sig figs, the mass of oxygen is 16.00. And so then we just get out our calculator, and you don't need to use parentheses or anything. You can just type it in. Your calculator understands the order of operations, so do not overthink this. So 40.078 plus 2 times 14.01 plus 6 times 16. When we calculate formula masses, we're not going to get a crazy number of sig figs, but we do sometimes get more than we really, really need. There's 2 ways to think about sig figs here, because we've got mixed, multiplying, and adding. We could do this, though, with just adding, right? This plus this plus this plus this, however many. If we were just using adding, it would go by the number of decimal places. And so that's what I would recommend doing, is going by the number of decimal places. So if you're rounding this, it would be 10 atomic mass units. The thing is, though, when we're going to use these types of numbers in calculations, and it's always better to have an unrounded number. So when you're calculating formula masses to use in a calculation, it's perfectly fine to just use everything that your calculator gave you. It's usually only like 1 or 2 extra digits. So 164.10 AMUs. And again, when we are rounding, we have to look at the next digit. I was grading some experiment 0 reports today, and sometimes we forget to round up, and then we get the red X on the computer. And nobody likes that. We talked about molar mass of elements, right? It's the mass in grams of 1 mole of atoms. Well, we can also talk about the molar mass of a compound. That's the mass of 1 mole of molecules, or 1 mole of formula units. It's calculated exactly the same as the formula mass, but the unit is grams instead of atomic mass units. And this is another one of those things where I'm not going to try to trick you with this and ask you, what's the formula mass? And you calculate it and you put grams on it. Wrong. I'm interested, can you get the number? Okay, we'll call that good. The molar mass has grams. A formula mass or an atomic mass, we're talking about the mass of just 1 piece, and that's where you have the atomic mass units. But after this chapter, we're not going to talk about atomic mass units very much at all. We're just going to do grams. So the molar mass of a compound is the same number as the formula mass. Calculate them the same way, it's just the unit's different because we're talking about a mole of stuff. And it's the same number because they set it up that way to make it easier. So, what is the molar mass of ammonia?
That's when we gotta go to the formula.
We need the formula. What's the formula for ammonia? NH3. It was on a slide earlier today. So that's NH3. So we're going to calculate it the same way. How many nitrogens in the formula? 1. So 1 times the mass of nitrogen, 1 mole of nitrogens. Here, let me do it this way. I'm just going to do it this way once. In a mole of ammonia, there's 1 mole of nitrogen. And nitrogen is 14.01 grams per mole, and the moles cancel out. And how many moles of hydrogen? 3 moles of hydrogen, and the mass of hydrogen, a mole is 1.008 grams per mole. So we add those up. You know you've done a lot of molar masses when you remember the molar mass of ammonia. Any questions? Molar masses get used as conversion factors for compounds just like they do for elements. So when you calculate a molar mass, do you have to do all of this with the units? No, you don't. I do think you should write something down so you can go back and see if, maybe it ends up being wrong. You want to go back and see what you did. So this is like the minimum you should write down. And sometimes people say grams per mole, or you can say that many grams is equal to 1 mole of ammonia. Okay. So just like we used molar mass to count atoms by weighing, we can use molar mass to count molecules by weighing. So we start with the mass of something, we go to the moles of something, and then the molecules. So grams of A, this is going to be our molar mass to convert to moles, and here we've got Avogadro's number, and we end up with number of molecules. Find the number of ibuprofen molecules in a tablet that contains 200.0 milligrams of ibuprofen. That's how much is in a regular tablet. They give you the formula for ibuprofen because we don't expect you to know that. I don't even remember that one, even though I really like ibuprofen. That's like, I'm a mom, and so that's the solution to any physical problem. My head hurts, take some ibuprofen. I sprained my ankle, take some ibuprofen. They don't ask anymore, they just go take ibuprofen. So the number of ibuprofen molecules, this really is a dimensional analysis problem. So I read the problem, and I'm going to highlight the numbers, 200 milligrams. And then we're going to go looking for what are we supposed to find? The number of molecules.
Could we change, to make it easier, could we change the milligrams to grams?
We can, yeah. So we've got 200 milligrams, and we're trying to end up with molecules. So we could do milligrams to grams, and then what's going to be in the middle? Moles. Grams to moles, and moles to molecules. Okay, I'm going to show you kind of a sneaky way to do this. 200 milligrams, instead of writing M, I'm going to write times 10 to the minus 3. Because that's what it stands for, right? That's what it means. Times 10 to the minus 3 grams. So we had milli there, and I'm writing what it means here, just swapping them. Worksheet 1, one of those early questions had you do that. This number is not in proper scientific notation, but it's not an answer, and your calculator doesn't care. So this is just 200 EE negative 3. Saved a step. So I've got 2 arrows left. I'm going to convert to moles, and then 2 molecules. This unit comes down here, and they cancel out. Moles comes down here, and they cancel out. If you wanted to put the conversion on there with milligrams and moles, milligrams and grams, it's absolutely fine. So this is the molar mass of ibuprofen. We're going to have to calculate that to plug it in. So that's why they gave us the formula. So there's 13 carbons times the mass of carbon plus 18 oxygens. No, 18 hydrogens plus the mass of times the mass of hydrogen, and 2 oxygens. I don't know where that came from. I got busy talking to students before class and I didn't eat my supper. A lot of times when I get to the end of a calculation like that, the Family Feud thing comes up in my head. Survey says 206.274. So 1 mole weighs 206.274 grams. Is that too many sig figs? Yes. Is that a problem? No. Having too many is not a problem. We can always round them off at the end. And then this one is Avogadro's number. That big old long number goes with the big old long unit. Takes up way too much space, 6.022 times 10 to the 23rd molecules for 1 mole. They abbreviated the 4-letter unit and not molecules. Again, didn't consult me. So 200 EE negative 3 divided by 206.274 times 6.022 EE23 equals, how many sig figs is this answer going to have? Which of these has the fewest sig figs? Well, 2 of them have the fewest sig figs, right? This is 4, and Avogadro's number is 4. And this one is probably 5. Yeah. So 3.838, that's 4 sig figs. I'm going to just copy down the next 2 digits. And then over on the side it says E20, that means times 10 to the 20. And then I'm going to round it 5.839, because this guy makes me round up. Is that a big number? It's a really, really big number. Is that reasonable? Sure. I mean, 200 milligrams is not very much. I mean, it's enough that you could see it. But molecules are crazy tiny, right? And so it's going to take a whole bunch of them. Any questions? I just had this brain fart that I didn't get 839, but I did.